In this video, we're going to be asking the essential question, what will make the equation true? So this is section 1.2. It's all about solving equations. And every time we solve an equation or an inequality, we want to ask what will make it true. And that is when we check our equations, we plug it back in because we're looking to see that we have a true statement. Now, the main difference between an equation and an expression is simply an equation has an equal sign. An equation is a full sentence with a verb. An expression normally does not. So a difference could be an equation is x plus 3 is 10. An expression is simply x plus 3. So once we set it equal to something, it becomes an equation because it has the equal sign, and that's the verb of the sentence. An expression lacks an equal sign, therefore we are not able to solve it. It can only be simplified if possible. So our first equation is pretty simple. 5x minus 2x plus 2 equals x plus 2 times 3x plus 5. And we have all sorts of different properties that allow us to solve equations. So we're going to start using them. You learned them in Algebra 2. So first thing we've got to do here is utilize the distributive property, and we need to follow the order of operations to get rid of these parentheses. So 5x minus 2x minus 2 equals x plus 6x minus 10. Next, of course, after we utilize the distributive property, we need to combine like terms, which is what I will do next. And I am lining up my equal signs and working down the page. 5x minus 2x is 3x. 1x plus 6x is 7x. Next, we need to solve for x. So let's get all the x's on the left. Let's get the integers on the right. So 3x minus 7x equals negative 10 plus 2. That's using multiple operations in order to isolate that variable. 3x minus 7x is negative 4x. Negative 10 plus 2 is negative 8. And x is 2. So solving equations just like you've been doing in Algebra 1, Geometry, and Algebra 2. Next, this is a rational equation, and we just saw rational expressions at the end of Chapter 1. Whenever we have a rational equation, we want to use the common denominator to eliminate the fractions that will allow us to solve. So going to do the same thing we were doing earlier using a common denominator, except when we just had expressions, we kept the common denominator. Here we're going to use it and lose it. So our denominators are 5, 1, 10, and 2. Remember, a common denominator is a lowest common multiple. So we're after a multiple, not a factor. 2 and 5 are factors of 10, but 10 is the least common multiple of 5 and 2. So we are going to multiply both sides of this equation by 10. And when we multiply both sides by 10, it's going to eliminate the fractions. So in this first product, the 5 and the 10 cancel 2 times. 2 times 3x is 6x. Not 2x, but 6x. There we go. So next, the 10 gets multiplied to the x. That, of course, is just 10x. Equals, multiplying through on the right, 10 times x over 10. The 10's cancel. We get x. Negative 5 over 2 times 10. 2 goes into 10 5 times. 5 times 5, 25. So utilizing the common denominator just eliminated all the fractions and makes this a very simple equation. 6x minus 10x is negative 4x. And then negative 4x minus x is negative 25. Negative 5x is negative 25. X is 5. So utilize a common denominator in order to eliminate fractions. And we are going to do that same option again. But first, it appears that we need to factor 2x plus 6. 2 and 6 have a common factor of 2. Let's take it out. 2 times x plus 3. That allows us to be able to see all the denominators factored and then easily surmise what the common denominator is. So, and there's actually, we can do this problem two different ways. First, let's do it by eliminating the fractions, just like we did in the last problem, by multiplying both sides by the common denominator. So remember, to get a common denominator, every factor within the denominator must be represented in order to form a least common multiple, just like we did in the last problem. So our common denominator is going to be 2, because we have a factor of 2. It's going to be x plus 3, and it's going to be x minus 2. So all three of these factors become part of the least common denominator. So on the left-hand side, when we multiply 3 over x plus 3 times 2 times x plus 3 times x minus 2, the x plus 3's cancel, and we're left with 2 times 3 times x minus 2. All of that is going to be left on the left-hand side. Next, 5, remember we factored him, 5 over 2 times x plus 3, when we multiply through by the common denominator, and it needs to be distributed on the right, the 2's cancel, the x plus 3's cancel, we're left with x minus 2. So 5 times x minus 2 plus 1 over x minus 2 times x plus 3 times x minus 2. The x minus 2's cancel, and we're left with 1, which we don't have to write, times 2 times x plus 3. So utilizing the common denominator just took us to this. So now let's simplify on the left. 6 times x minus 2, which will be 6x minus 12. And then let's keep going here. 5 times x, 5 times negative 2, 2 times x, 2 times 3. We can combine like terms again. That is 7x minus 4. So now we're down to a very simple equation. 6x minus 7x equals negative 4 plus 12. So that's negative x equals 8. And if negative x equals 8, then x equals negative 8. Let's do this problem one other way, and then we'll talk 1 or 2 minutes about the whole idea of restricted values here. So same problem. 3 over x plus 3 equals, and I'll go ahead and write the next one factored, 2 times x plus 3, and then 1 over x minus 2. We can also do this problem by establishing the common denominator across the bottom, and then before we dismiss it. So what is this one missing? This one's missing a 2 and missing an x minus 2. So 2 times 3 times x minus 2. It's the same what's missing type preparation. What is this guy missing? X minus 2. And what is this guy missing? He's missing a 2, and he's missing an x plus 3. So We just established the common denominator all the way across the equation, just like we did in the previous chapter. But the good news is now is that because it is an equation, I no longer need that denominator. So now I can just solve it just like I already did. This is 6. 6 times x minus 2 equals 5x minus 10 plus 2 times x plus 3. So 2x plus 6, 6x minus 12, 7x minus 4, negative x equals 8x equals negative 8. Now, before we move on and we end this, let's take a look at the original given equation, which was 3 over x plus 3, 5 over 2 times x plus 3, and 1 over x minus 2. Restricted values are going to be negative 3 or positive 2. So x could not be any one of those values. Therefore, does that give x equals negative 8 a legitimate answer? Yes, it does check. So restricted values are also a thing when we are solving equations. So there you go. That is a brief review of solving advanced algebra equations.